Hello students, Mr. Courtney here. In this video we're going to be talking about the mole concept and we're going to be discussing molarity. Our objective here is to be able for us to define molarity, calculate molarity. We'll also determine the mass of a substance required to make a given molarity of a solution once we know the volume required, and we'll be able to calculate moles of solute in a given volume of a solution of known concentration or molarity. So what is a solution? A solution is a mixture of a solute and a solvent. And in chemistry, most of the substances we use, or most of the chemicals we use, are in the form of a solution. That means we've taken a chemical or a substance and dissolved it in water, and we've created what's called an aqueous solution. So the substance being dissolved is the solute, and the substance doing the dissolving is the solvent. So if we take a mixture of sugar and water, we dissolve sugar in water. Sugar is being dissolved, so sugar is our solute. Water is doing the dissolving, so water is our solvent. So based on the amount of solute you put in the solution, that is known as a concentration. So based on the amount of solute you have in a given amount of solution, we call that the concentration. And when you think of, if we use sugar as the example, the sweeter it is, the more concentrated it is. So we have two pictures here, picture A and picture B. Picture A has 100 milliliters of water with 50 grams of sugar. And picture B has 100 milliliters of water with 5 grams of sugar. We need to determine which one is more concentrated, and I explain. So we have to look at the amount of solute dissolved in each one. So we have 5 and we have 50. Notice the volume of water is the same. So now we can say that picture A is more concentrated because it has more solute in the same volume of water. Right? So if you were to taste it, because it's sugar, you would see that picture A is sweeter for the same one. So it would be more concentrated, the same volume of water. Now that could change. The answer could change based on the volume of water used. So keep that in mind. Now, molarity. Molarity is the number of moles of solute in each liter of solution. So when we look at molarity, it is a measure of concentration, but instead of just measuring the amount, we go by the number of moles in each liter of solution. How do we calculate molarity? We take moles of solute and divide it by liters of solution. So we have our moles of solute and we divide by liters of solution. And that gives us the units of moles per liter. Now, the big M, uppercase M, which represents molarity, and moles per liter, moles divided by liters, can be used interchangeably. So there will be questions where we're given M, and we have to convert that into moles per liter. Or we're given moles per liter, and we need to convert it to M. So you have to be able to understand this. Now you see 1M8Cl. So you see this written sometimes. What it means is that it's 1 molar hydrochloric acid. So this is how it is read. And what that means is that we have 1 mole of hydrochloric molecules in 1 liter of solution. So in each liter of solution, we have 1 mole of hydrochloric molecules, or HCl molecules. Now, how do we make these solutions? And basically what we do is that we take the weighted amount of solute. So if you want 1 mole in 1 liter, you find the mass of 1 mole of the substance. So you find the molar mass. This calibration mark tells us that is the volume of solution that we're going to make. And in this case, we're going to assume it's 1,000 milliliters or 1 liter. We add some distilled water to bring it to a certain volume so we can dissolve the solute. Once we dissolve the solute, we'll go ahead and we add more solution, more of the liquid or the distilled water, and then we fill it to the mark until we get to a desired amount. And that's just the basics of creating a solution. Now, if we have 3.0 moles of sodium chloride dissolved in 2 liters of solution, what is the molarity of the solution? So we ask for molarity, and we know that molarity is moles divided by liters. So we start with our 3.0 moles of sodium chloride, and we divide by 2 liters of solution. So that's 3.0 divided by 2.0. and that would give us 1.5 molar sodium chloride. Well, that means we have 1.5 moles of sodium chloride in each liter of solution. All right, we asked, what is the molarity of a solution if 2.50 moles of sodium chloride are dissolved in 5.00 liters of solution? So we're given moles and we're given liters, similar to the first one. So we do our 2.5 moles of sodium chloride divided by our 5 liters of solution, we get 0.500. And be careful, pay attention to your significant figures. We needed 3 significant figures, so we need to give 3 significant figures in our answer. So in this one, you're given grams and you're given milliliters of solution, and you ask what is the molarity. So you have to think about what is it you need to calculate molarity. To calculate molarity, you need moles and you need liters of solution. So that means we have to convert our grams to moles and then convert our moles to molarity. So we start with our grams of lithium chloride, 25.0. We now divide by the formula mass of lithium chloride to get our moles, because in 1 mole of lithium chloride we have 42.394 grams. Now we divide by the volume of solution, which is 500 milliliters, but we want it in liters. So we have to convert our milliliters to liters, because we know there are 1000 milliliters in 1 liter. And that leaves us with our desired units. All the units cancel and we're left with moles divided by liters, which is what we want. So we multiply 25 by 1000, then divide by 42.394, and that gives us 1.18 molar. So that's our molarity of this lithium chloride solution. All right, similar to the previous one, we have 35.0 grams in 750 milliliters of solution. We want the molarity. So again, we start with our grams of magnesium nitrate, divide by the formula mass, that is how many moles in 1 mole, we have how many grams? 148.313. We left with moles, divide by our volume in milliliters, then convert our milliliters to liters. And again, we're left with the desired units of moles divided by liters, moles per liter, which is molarity. We multiply and divide and we get 0.315. Again, we were given 3 significant figures here. We have 3 significant figures, so our answer must be given to 3 significant figures. Now, how many grams of potassium chloride are needed to prepare 2.50 liters of a 1.34 molar solution? So now we're given liters and molarity. So if you want to think about it, what are you given? What do you want to find? You're given liters and molarity, and you want to find grams. So that means you're going to start with your liters of solution, convert your liters to find how many moles of the substance you have in that given volume, and then convert your moles to grams. So we start with our liters of solution, and then we know we have 1.34 moles in 1 liter, because that's this here is our molarity. This is our molarity here, 1.34 moles per liter, which is the same as this here. So that leaves us with moles only. Now we can convert our moles to grams by multiplying by the formula mass of potassium chloride, because we have 74.551 grams of potassium chloride in 1 mole. Our moles will cancel, and that leaves us with grams of potassium chloride, which is our desired, because we were asked for how many grams of potassium chloride. So you just multiply these out, and we need, again, 3 significant figures. We get 250 with the decimal. That gives us our correct answer. Okay, now similar problem. You give how many, you want mass of copper 2 sulfate. Now the important thing is here, and I should have mentioned this earlier, is that you need to be careful when writing the formula of your compounds. Now remember, you need to write out the ions and then do your method to find the correct formula. So not because it's copper 2 sulfate, you're just going to think it's copper CuSO4. It works out to be CuSO4 because copper is +2 and sulfate is -2 in terms of their charge. But when you're doing these questions, make sure you take the time to go through that, and that will save you some problems. So now we're starting with milliliters instead of liters. So we start with milliliters. We convert our milliliters to liters, because in 1 liter we have 1,000 milliliters. So we have our liters of solution. And we know we have 2.50 moles in 1 liter, so that gives us moles. And then we multiply by the formula mass of copper 2 sulfate, 159.608 grams in 1 mole. So that leaves us with grams of copper 2 sulfate, multiply and then divide, and that gives us 507 grams of copper sulfate. And again, 3 significant figures. Okay, so here we want to find the volume of water that is needed to create a 1.5 molar solution of potassium sulfate if we have 68.5 grams. So we're going to start with our grams of potassium sulfate. We find out how many moles of potassium sulfate we have, because in 1 mole we have 174.258 grams of potassium sulfate. Now we know how many moles we have, and we have the molarity. So we're going to find out how many liters of solution we have now. Because in 1 liter of water we have 1.50 moles. That's what we want. So we can now find how many liters of water we have. And remember, it's all about working with the units. Let's go back, because we start with grams. We would need our grams to cancel. So we divide by grams of potassium sulfate. In 1 mole, we know how many grams of potassium sulfate we have. And we're given the molarity of the desired solution. So in 1 liter of water, we want 1.50 moles. So we divide by 1.50 moles of potassium sulfate. Moles of potassium sulfate will cancel, and that leaves us with liters of water. So you divide 68.5 by 174.258 and by 1.50, and you get your answer of 0.262 liters of water. Okay, so that takes us almost to the end of this. Now on the next, all I'm showing you here is how you go about from the different ones. All right, molarity, we haven't talked about molarity, but we talked about molarity. So it shows you how you can go from mass of solvent to moles of solute to molarity and all these stuff. So that is important. That will help you. Some of it is very good, especially if I give you a question, if you have questions with density or so, that would also help. So it will be very useful to know this piece of information here. So that is the end of this video. Until the next time, I'm out. Blessings.